What I have here is a three-way switching circuit. I have 1, 2 three-way switches and a load, a light. I'm operating at 48 volts on this circuit to keep it within safety parameters. Obviously, where it hooks up on a board, it's all exposed, so less than 50 volts is considered safe. Now how this works is power comes into one switch, follows one of the 2 traveler wires to the second switch, comes out the power terminal of the second switch, turns on the light. Now terminals often get confused on these. How this works is these terminals are color coded. The power going in is going to be a darker color, usually black. The power going out on the traveler wires is usually going to be brass. So it's a noticeably different color, so it's hard to mess up hooking them up. Same thing here. The travelers are on the brass colored terminals. The hot wire comes out right here on the darker colored terminals. All the terminals are going to be color coded. Anything that's silver or white would be in neutral. Anything that's other than silver and white will be for the higher wires. Now how this works, it's kind of simple. The load is on, but I can turn the load off from this switch, and I can turn the load on from this switch. And I can turn the load off from this switch. Turn the load back on from this switch. So three-way switching allows me to operate the same load or the same set of lights from different terminals, from different points. 2 different doorways, 2 different areas, 2 different rooms. Now number-wise, if I take the measurements here, the power coming into this unit right there is 49 volts. Measuring power to this circuit right here, power coming in on the power terminal, and measuring straight across to neutral, we have 49 volts. Now if I measure one side, it's 49 volts. The other traveler wire would be 0 volts. Well, we're reading induction 1.9. That is an induction voltage. If I flip the switch, we now have our 49 volts on this terminal. We now have our 0 volts or induction on this terminal. Now measuring on this switch over here, same thing. One side right here we got 0 volts. The other side we have our voltage. I flip the switch. Now we have 49 volts on this side, 0 volts on this side. Well, my induction voltage. Now how this works, it's kind of simple in how this is going to work right there. But if I bring up the drawing you see on the website right there, you have a simple 3-way switch circuit. Power comes in 120 volts through the terminal to the 2 traveler terminals. These 2 wires here be the travelers, and this would be the second switch. Under one condition, power is on through switch 1, but now if I operate switch 1, the load turns on. If I operate switch 2, the load turns off. It's interrupting the path of current. Operate switch 1, the load turns back on. Operate switch 2, the load turns back off. So 3-way switching isn't really complex, not really complicated at all, but one of the biggest problems that happens with 3-way switching is people hook them up the wrong way. The terminals are color coded. It's not hard to understand what they work and how they work. It's simple operation. The hard part is, well, going back and forth through long areas of wire. So 3-way switching.